All right, the next example I'm going to work through is one very similar to all the rest of these. These are essentially all same problem, different numbers, just depending upon what you're given in the problem is what happens with the substitution. So let's see what we have here. This is the square root of, we have a subtraction, we're subtracting two squares. So trig substitution, always the same orientation. Since this is subtraction, the square root of this first piece is the hypotenuse. The variable has not yet been spoken for, so the variable is going to be vertical. The variable is the square root of 5x squared. So we can write that as the square root of 5x. I like to write my radicals last because sometimes it's not neat enough and I don't know for sure where the radical ends. I want to go ahead and write this. That way there's no confusion. The x is not inside the radical. You don't need to do that, but I like to write it this way so it eliminates any confusion of thinking whether or not that x is inside the radical. And then finally, since the radical is the last piece, there we go. So this triangle is labeled correctly. We choose the function that does not involve the radical. That would be opposite hypotenuse. That's going to be sine. Sine theta is opposite over hypotenuse. The hypotenuse is 1. I don't want square root of 5, so I'm going to get rid of that. So this implies 1 over radical 5. You do not need to change that form. Just leave it as 1 over radical 5. And the whole point of this is to find the differential. The derivative of sine is cosine, and constant multipliers multiply along. And so we found the differential. The next is you choose the function that does involve the radical. Well, that's adjacent hypotenuse. That's cosine of theta is adjacent. And this is convenient over hypotenuse is 1, so that's finished. Again, notice if you choose sine here and label this triangle the way I'm advising you to, then if you choose this to be sine, this will be cosine. So the substitution is exact. And it turns out we don't need this piece because there is no stray x in the problem, but we do need this as a bridge to get to the differential. So what do we have here? The radical is cosine theta. And what's the differential? The differential is 1 over the square root of 5 cosine theta d theta. I'm going to rewrite all this, make this look nicer. And so we have 1 over radical 5 integral cosine squared. Remember our rule here. So this is now proceed as before. Use the half angle identity. This is 1 plus cosine 2 theta d theta. So I'm going to write this as now 1 over 2 radical 5. The antiderivative of a constant is you reattach the variable. The antiderivative of cosine, right, is sine, but we have to use the 1 over a rule, 1 over a. So all these little pieces come in from all over our work so far. There's the 1 over a rule, there's the trigonometric substitution, there's using this little identity to get from cosine squared to cosine to the first power. Again, we have 1 over a rule. We're going to use another identity here. So you do need to keep your wits about you, and as much as anything, you need to practice this process so that you have this sort of at the tip of your brain. All right, so what do we have? 1 over a rule. The antiderivative of cosine is sine. And we've taken into account the chain rule because of 1 over a. All right. Now, here's the problem. Theta we can get from here because we can back solve theta is sine inverse of this expression. But if this were simply sine of theta, we could substitute this, but it's not. It's sine of 2 theta. So you don't just get to double this. That's not the way it works. You need to convert sine of 2 theta into an expression involving only 1 theta. And so here's the piece. One of the reasons I went through this example is specifically to get to here. Whenever you're doing this trig substitution and you generate sine of 2 theta, this will happen frequently enough that you need to know this. Sine of 2 theta, there's an identity. And you'll use this enough that it'll be fresh in your mind. If nothing else, just make you a couple flashcards and memorize these identities. But here we go. Sine of 2 theta. Notice, this 1/2 is always here because of the 1 over a rule. And then we know that sine of 2 theta, this is one of the identities you generated in trigonometry. This is 2 sine theta cosine theta. 2 sine theta cosine theta. That's required because now this is theta, not 2 theta, and we can translate back to the x variable because of these expressions. These need to be theta, theta, so that you can do this back substitution. If it's 2 theta, it doesn't work. All right? There's always going to be a 1/2 here. There's always going to be a 2 here because of the identity, and so these are always going to cancel. Theta plus 1/2 times 2 sine theta cosine theta. And so these 2's cancel. All right, it's substitute the values. Theta, what is theta? Theta we know is sine inverse of x radical 5. All right? Theta is sine inverse. All right? Plus, I need sine theta. What is sine theta from my list? Sine theta is x radical 5. Times, what's cosine? Cosine is the radical. 1 minus 5x squared. And as soon as everything is in terms of x's, you are out. So you do not need to simplify this at all in any way. Once you translate back to the original x variable, you're finished. Yep.